start off with a card game between you and a partner. We've got 22 people in here, so we've got 11 groups. I want to demonstrate the way the card game works first before you guys get into your groups. So each group, I'm going to hand a set of 5 cards. Every set of 5 cards will have 3 kings and 2 aces. You win if you get a pair. So person A, whoever the dealer is, so to speak, you're going to mix the cards up. You're going to let your partner pick 1 card. They're going to turn it over and record it. And then they'll pick a second card. You do not put the first card back. So the first time you're picking out of 5, the next time you're picking out of 4. We're on page 15. This is where you're going to record this. So you guys are going to need to play through with one person being the dealer and then switch roles so that each person has a completely filled in table. Do you mind playing with me here? All right, pick a card, any card. All right, turn it over. All right, so we got a king. She would record king. And then I'm going to mix them up from the remaining 4 cards. She wants to get a pair, so she's hoping for what? A king. What's her chances of pulling a king if she already pulled a king out? 50-50, because there's 2 aces and 3 kings total in here. Can pull a card. Second card was an ace. So she did not win. So in that bottom row, we would write winner, no. And then you're going to do this again and again and again. You guys can trade rolls back and forth, or you can let one person finish all the way out and then trade rolls so that the other person can play. All right? Mix up the cards each time. Record your first card. Do not put it back. Mix the cards up and pick your second card. And then record whether you got a pair and you were a winner or not. All right? Find your partners, and I will pass out the decks of cards to you guys. While some groups are finishing up, I'm going to come around for those that are all the way finished, and I want to record down how many games you won, because we're going to use the whole class data to try to find the probability for winning this game. All right, how many games did you win, sir?
1 out of 2.
You won 1. All right. You won 5. 5. 3. How many times did you win? 3. 6. 2. How many times did you win, Grayson?
5 out of 10.
5 out of 10. You won?
7.
Ooh.
You cheated half the time. Girl, I pulled the cards.
Right. How many times did you win?
3.
3. 4.
5.
5.
6.
6. Are you guys done playing now?
6.
6 times?
5.
5 times? All right. Go ahead and take those. Thank you. All right. 5 wins. And Max?
I got 4.
Oh, yours was 4. Sorry. Yours was 4.
I got 3.
You got 3. Okay. Justin, you had? 4.
Right.
Yep. Supposed to do 1 at a time. Okay. How many wins did you have, Jenna?
6.
6.
5.
5. If I can get a couple volunteers to add up the numbers that are on the screen so far, then we'll just have a couple extras to throw in here. But if we could get a running total, that would be fantastic. Also, once we get all of our numbers, it's going to be out of how many? How many games will have been played total in the room? 220. Because I didn't play this time. Every person played 10 games, 22 people, so this is going to be out of 220 once we get all of our numbers here. 12, 23, 24, 25, 30, 40, 49, 55, 61, 66, 77, 88. All right, I added them in my head, so I'm hoping that some other people can offer. Did anybody else add the numbers on the board? What did we get? 88? Okay. Anybody else get 88? Just want to make sure that we're all adding them correctly. All right. How many more rounds do you ladies have? One more round? Okay, cool. While they are finishing that piece up, I want you guys to see if you can fill in these first two boxes here with the probabilities. What's the probability that the first card you pull is an ace? What's the probability that the first card you pull is a king? See if you can fill that piece in. So top box, what's the probability that the first card that you drew was an ace? What was the probability that the first card you drew was a king? All right. Carissa, how many times did you win? 4 times. And you won how many times? 5 times? So we're going to add another 9 to this. 97. 97 out of 220. Can somebody pop that in their calculator and tell me what that is as a decimal? I'm sorry, one more time. 0.441. So roughly what percent then? About 44.1% ballpark is what we're coming up with from our data. Did anybody in here have a 44% chance win when you played individually? No. Anybody come close to 44%? A lot of 40%, some 50%. Why is our class average 44? Like, what are we making use of here? Why did I want everybody's data instead of just individuals, like 1 or 2 individuals? Law of large numbers. The more times I repeat something, the closer and closer I will come to the theoretical probability. We're going to calculate the theoretical probability here now. What was the probability that the first card you pulled was an ace? 2 out of those 5 cards. And a king? 3 out of 5. This is called a tree diagram. Tree diagrams are super, super useful for calculating probabilities where you do something and then you do something else. And if you wanted to take another step further, we could look at a third step. In this case, we had 2 steps. You drew your first card, and we had chances on that, and then you drew your second card. So the chance that you drew an ace was 2 out of 5, assuming that you drew an ace. How many cards are left now? 4. What's the chance that the second card was also an ace? 1 out of those 4. This is the conditional probability here. This 1 out of 4 is conditional probability. I would say that this right here, this is the probability of the first card being an ace. But this probability that we just wrote down here, this is the probability that the second card is an ace, given that the first card was already an ace. So remember, we read that little line as given that. Before we fill in anything else here, Is drawing an ace the first time and drawing an ace the second time, are those independent events? Or does one event influence the other? One event influences the other. My probabilities changed when I went to the second event. What I was describing, pulling an ace, didn't change, right? But my chance of pulling an ace the second time wasn't the same as the first time. So these are not independent events. Tree diagrams are really, really, really good for things that are not independent. If we drew an ace the first time, what was our chance that the next card we pulled was a king? 3 out of 4. This one right here, this is the probability that the second card was a king, given that the first card was an ace. So if you pulled an ace the first time, do you have a good chance of winning? No. I want to figure out what our chance of winning was. Winning is getting a pair, right? Ace for first and second. If you drew an ace the first time, let's figure out what the chance was that you won. To find the probability for first ace and second ace, we are going to multiply these two probabilities together. So we're going to multiply 2 out of 5 to 1 out of 4. How do I multiply fractions together again? Straight across, top to top, bottom to bottom. So this would be 2 out of 20. 2 out of 20. Can I reduce that? That'd be 1/10, right? 1/10 or 0.1. Let me change how I have that written just a little bit. One out of 10. To find this probability, to find the probability of first ace and second ace, the probabilities that we just multiplied was the probability of pulling an ace the first time. So probability of first ace times the conditional probability, the probability that the second card was an ace, given that the first card was an ace. So on my tree diagram, I take this initial probability and then I multiply it by the conditional probability. If I use that same process, what's the probability that the first card was an ace but the second card was a king? You said it's what? Sorry, I just couldn't hear. 6 out of 20. The probability that I pulled an ace stays 2 out of 5. The probability that I had a king as my second card was 3/4. So we had 6 out of 20, or 3/10. 0.3. See if you guys can fill in the bottom. Assuming the first card you pulled was a king, what's the probability the next card you pulled was an ace? Assuming the first card you pulled was a king, what's the probability the second card was a king? And then calculate those compound probabilities at the end there. We're going to check back together here in about a minute or so. If you pulled a king for your first card, what's the chance you pulled an ace for the second card? 2 out of 4. What's the chance you pulled a king as your second card? 2 out of 4. So let's find these. They're called compound probabilities because I'm multiplying probabilities together. I want to know the probability of more than one event happening at the same time. Yes, sir?
Oh, where did you get 2 out of 4 from?
2 out of 4. So if you pulled a king out first, how many cards are left in the deck?
4.
4 cards. It started off with 2 aces and 3 kings. So if I pulled 1 king out,
Oh, but you have 2 left out of
we have 2 kings left out of those 4 cards. Yep. Good questions. All right, so compound probabilities. If we pulled a king the first time, that was a 3 out of 5 chance. Chance I pull an ace as my second card was 2 out of 4. When I multiply those together, I get what? 6 out of 20, or 3/10. What was the chance that my second card was a king? 6 out of 20 again. 3/5, I pulled a king the first time, times 2/4 that I pull a king the second time. So 6 out of 20, or 3/10. What do you get if you add all of these compound probabilities together? 10 out of 10, or even if I look at the unreduced ones, 2 and 6 and 6 and 6, I get 20 out of 20. So this all adds up to what whole number? All adds up to 1. That will always be the case on your tree diagram. It's going to add up to 1 every single time. I want to find the theoretical probability of winning this game. So I'm going to copy that tree diagram over here again. Which of these end results would mean that you won? If you get two whats? 2 aces or 2 kings. So which one of these has me getting 2 aces?
The first card.
First one, ace, and another ace. So that was a 1 out of 10 chance, right? So 1 out of 10 plus, which other end result has me winning? Very last one, king and king, because you had to have a pair. King and king. 3 out of 10. Why am I allowed to just add these? Why don't I have to worry about subtracting out an intersection? Yeah, these are disjoint. These are mutually exclusive. If I pull an ace the first time, it's not going to overlap with anything that would have me pulling a king the first time. These are mutually exclusive events, so I can add their probabilities together, and we get an overall probability of, what was the chance of winning at this game? 40%, 4 out of 10, or 0.4. Does that mean our law of large numbers lied to us? No, it was close. We got it at 44%. That's ballpark, right? Would anybody have guessed before we actually started calculating this that the chance of winning was 40%? Like, did anybody know that right away? No. So 44% gets me in the ballpark if I'm just doing repeated trials over and over and over. If I had you guys do this again, and we added that on, so now we had 440 games, what do you think we would see?
Closer to 40.
Probably be closer to 40% on that empirically collected data. I want to know What is the probability that the first card was a king if we know the person won the game? That's down at the bottom right here, number 5. What is the probability that the first card was a king given that the person won the game? So I'm going to write down what we're after here. Probability that the first card was a king given that they were a winner. Does anybody remember our formula for conditional probability? We wrote this down yesterday. The formula for conditional probability. Yes, so this is the probability of A and B happening together. So the first card was a king, and they were a winner, divided by the probability that they won. I realize this is way down at the bottom of my screen, and I apologize for that. So let's see what we can do here. What's the probability that you won if you drew a king first? 3 out of 10. So that's the top of my fraction. What did we say the probability of winning overall was? That was my empirical data. What's the actual theoretical data? 40%, or 4 out of 10. Pop that into your calculator. 3 out of 10 divided by 4 out of 10. Three out of 10 divided by 4 out of 10. Or 30% divided by 40%. 75%, because this would be 0.3 divided by 0.4 if I wrote it in decimal form instead of fraction form. This is 3/4 or 75%. So if you were a winner, chances are you drew a king first. That's what we just said here. If you were a winner in a game, chances are 75% chance that your first card was a king. I want you guys to look at your collected data. The times that you won, what did you typically draw first? King. That's what this says right here. All right. Big ideas for today. We have our general multiplication rule. I do want to make sure that you guys are familiar with the symbols for and or, because on the formula sheet that you guys get to use on the test, on the AP Stats exam, and therefore on our chapter test, they use this notation. They don't write out the word. So to find the probability of A and B, I take the probability of the first event times the probability of the second event if I know the first event happened, times that conditional probability. That's the same as multiplying along my branches for the tree. If A and B are independent, then the chance that B happened, given I know A happened, is exactly the same as just B happening. So then I can just multiply the probability of A and B together. This is the big idea for how my tree diagrams work. We usually write the probabilities themselves on the branches and then what the event is at the end of that branch. At the end, all of my compound probabilities, all of my little leaves on my tree have to add up to 1. If it doesn't add up to 1, you made a mistake in multiplying somewhere. The probability that an event happened at least one time, so it could be one or more, is the complement that it didn't happen at all. 1 minus the probability that it didn't happen at all. On the next page, dear. Get that copied down into your notes. Take a couple minutes to try to check your understanding down at the bottom. We're running kind of tight on time, so I apologize. We're going to go over that at 9:40 so that I know that we have enough time to go through all of those pieces. It was brought to my attention that the 5.3 homework had a due date of tonight on it, even though I told you guys it was due tomorrow, so I did go into Canvas and change that. It now says that it's due tomorrow.
The C notation.
This little C right here, that means complement. So if this has a 40% chance of happening, this one has a 60% chance. It's the complement. Or the probability that this did not happen. So in our game, we had, you could either draw a king or an ace. Those were the two possibilities. So either this happened or that happened. Yes, sir. Okay, two, so if it said that we're gonna select one subject, and then we're gonna go select another, what's the probability that this person said this and then that person said that? That would be something we would use a tree diagram on. So this one right here, probability that neither perverted grade A, we are gonna multiply together.
This is talking about the whole table.
Yes. Neither preferred grade. So 26 out of 94 did preferred grade. So I would add these three or two. I want 26 to the number of people that didn't.
Yeah, 68.
I want 88. And then for the second subject, I would take the same probability, 68 out of 188 by the end, which means the same thing as squaring.
Oh, okay.
If it was for 3 people, I'd multiply by
Oh,
3 times. You're welcome. I know you guys probably have not had a lot of time with the questions down below, but we have hit that time where I want to start talking through it now. So you'll take this,
Just this whole thing?
yep, that whole fraction and multiply it by itself. Oh wait, how did you get out of 188?
Because I multiplied this by top too.
No, it'd be out of 94. So 68 out of 94 times
And then
another
times
68
that.
out of 94.
Okay,
Mhm.
okay. Okay, I'm just.
All right. Construct a tree diagram to model this chance process. What's our first choice? What's our first split in the branches? What's the first thing that they're describing? Republican and Democrat. How many states went Republican? How many states went Democrat?
30.
How many states do we have? 50. So my first branch, 30 out of 50 Republican, 20 out of 50 Democrat. If you want to change them to decimals, you can. You don't have to. What's the next thing that they describe? Something else that I would use as branches. continental versus not continental. What do they mean by not continental? Alaska and Hawaii. Those are not connected to the rest of the states. All the rest of the states, you can drive from one to the other. You cannot drive to Hawaii. You could drive your car into a boat and they could ship it to Hawaii. You could drive your car to Alaska, but not without going through another country to get there. All right, so Republican, 29 out of the 30 were continental, 1 out of the 30 was not. For Democrat, 19 out of those 20 were continental, 1 out of the 20 was not. So how do I find my little leaves?
A and B.
We're going to multiply. So I'm going to take 30 over 50 times 29 over 30 to get the probability that they were Republican and continental. 30 over 50 times 1 over 30. This will give me the compound probabilities. So I end up with 29 out of 50, 1 out of 50, 19 out of 50, and 1 out of 50. If you write them as decimals, that's fine. But they should all add to 1. So watch your rounding if you write them down as decimals. What's the probability that a randomly selected state is in the continental U.S. and it went Republican in the 2016 election? $29 out of 50. Continental and Republican. That's this one right here. The order that they write these conditions down in does not matter. If we selected 4 states at random, what's the probability that at least one state is in the continental U.S. and went Republican? I'm going to use my 1 minus none. If this is the probability that something is continental and went Republican, what's the chance that it doesn't meet these criteria? 0.42. If I want to know about 4 states, I multiply that by itself 4 times. And from there, I can do 1 minus that value, which would give me 96.89.
Are you staying after today?
I am staying after today. Unfortunately, I cannot stay after tomorrow because I had an unplanned dental appointment that I have to go to. But today I will be after school. Have a great one, everybody.